Hi, my name is Anwesha Mukherjee, and I'll be discussing my research project from IBM Research during 2022 with my mentors Vagner and Alex, entitled ImpactBot, a chatbot that leverages large language models to help researchers robustly identify potential negative impacts and mitigation strategies. To begin, I'll start by addressing the impact statement, what it is, and the problem with writing them today, before detailing our approach to solving this issue, our user sessions and design takeaways, and give a brief demo. Then I'll address some new work with generative conversation agents using GPT-3 and the future with creating impact statements with ChatGPT before talking about our final takeaways. Impact statements are designed for researchers to be able to anticipate how novel applications will impact the world, that is, both social harms and social benefits, and help steer research in the right direction. However, impact statements have challenges. You have to define the research project succinctly, foresee impacts from a basic implementation, and most importantly, overcome common positivity bias to be able to identify different areas of impacts and address the shortcomings of your project. In fact, in terms of positivity bias, a survey of 2020 RoBERTa impact statements found that 67% mentioned positive use cases, whereas 23% only mentioned negative use cases, and 8% only mentioned how to address the mitigation, solving, or addressing strategies for any negative impact. Can we simplify writing and editing impact statements so that it's easier to overcome positivity bias, knowing that the bandwidth of human intervention is low, when there won't be many ethicists available and it's not time efficient or good for resources? First, we have to start with the data. We can harvest the RoBERTa impact statements from 2020, which are compiled with qualifiers, word counts, and domains and categories by Paul Sedil in 2021, so that we can train and evaluate a fine-tuned model. I conducted manual annotations by combining macros, category indicators, and some level of manual tagging for approximately 2,000 examples, 1,000 for training and 1,000 for evaluation. Then we get two binary problems. First, the use case. Does the impact statement mention a potential negative impact or use case? Second, the mitigation strategy. Does the impact statement mention a strategy, that is, mitigation, solution, or avoidance, to address a potential negative impact? Then we can denote a control flow. You start with the use classifier. By addressing whether or not there's a negative use, we can determine whether or not they should then check if they've addressed a mitigation strategy. If not, they should restart, being prompted to edit their impact statement. But if they have, they can move on to mitigation in the same pipeline, except in this case, they'll then be fed a deeper question, at which point ImpactBot's job is done. However, we need to make sure these decisions are explainable for human interfacing. Thus, instead of integrating just a classifier, we use three types of models: a summarizer that can help researchers see if they're getting the intended takeaways, a question answering system, which helps researchers identify machine error, but also if the impact bot is actually isolating the correct types of impacts, and finally a classifier, which actually sees if researchers are satisfying the objectives and making the improvements we need. The summarizer we use is a Facebook BART CNN model, which specifically performs well on direct summarization. Then we use a QA model, specifically the distilled RoBERTa from DeepSet, which is an extractive model with Squad 2.0. Squad 2.0 pre-training is especially important because it allows for more uncertainty. This is great for impact statements that might not have a potential negative impact listed when we're asking the QA model what the potential negative impact is. And by using the distilled model, it's more efficient. And finally, we fine-tune a RoBERTa base model across 14 epochs and NeurIPS data for specifically one impact classifier and one mitigation classifier. This is more efficient and transferable than using joint classification, and the label domain is then restricted to two binary decisions that allows us to use a softmax head. To more so account for machine error, we have to think about two things. First of all, in terms of our sample size, you traditionally want approximately 5,000 training examples, whereas we only have about 1,000. Secondarily, there's a distributive imbalance in this case, where there could be an accuracy and F1 difference, especially with a high rate of false negatives. This is as a result of the positivity bias in the 2020 NeurIPS data, where we saw that 67% mentioned a positive use case, but still, almost 80% didn't mention a negative use case, and almost 95% didn't mention a negative use case's mitigation strategy. This can create extreme room for false negatives, with the classifier's ability to simply say that all of these cases don't mention a negative impact. To be able to better identify positive mentions, that is, a mention of a negative use case, we needed to then emphasize the importance by weighting and biasing any of the positive use cases to have more effect in training. This allowed our fine-tuning results to then yield 92% for the use classifier and 87% for the mitigation classifier. In our revised process, we see that we have explainable decisions using the summarizer and QA model that stack atop the use classifier. We also stack the QA model atop the mitigation classifier. Now, the QA model would identify a negative impact if the use classifier says yes, and still attempts to identify a negative impact if the use classifier says no. In the case that it says no at the use or mitigation classifiers, users are given a rewrite prompt and output specifically designed for what they should do next so that they can restart the process with some more information. Secondarily, the QA model, however, allows the user to be informed on whether or not the classifier might have performed wrong. That is, the classifier can sometimes get it wrong. We're only 92 and 87% accurate, in which case the user is permitted to say the bot is wrong, and this allows us to go back and fine-tune the RoBERTa model more. In our user sessions, we conducted sessions with 12 different participants across various fields of study for different industry and academia professions. In terms of our takeaways, then, we realized how important clarity of use was. That is, specifically instructing users on how they should input to ImpactBot and what they should do, and giving them a log of progress so that they wouldn't be waiting without information. Secondarily, we thought about leading questions. To ensure that the users get to the right conclusions, after a couple of user sessions, we reran the user sessions after giving them more leading questions. For example, have you considered what negative societal impacts your projects may have? In doing so for the first 3 participants, we yielded better results in what they were editing so that they were more effective in getting the best results out of ImpactBot. Then we think about error admissions. Specifically, we give the user the opportunity to say, hey, we might not get everything correct. Can you please correct us? And finally, we think about the listed thoughts. To ensure that the user has an easy time reading and parsing through ImpactBot's information, we give a sequential series of answers as our answering format so that they can see the taxonomy of how ImpactBot is processing the information and what it does next. Participants were able to then see how they can grade their impact statements on some kind of scale or rubric, and it allowed them to think more deeply, including forcing them to overcome positivity bias to address some of the negative impacts they potentially didn't want to address. This was especially valuable if they could also then preempt some of the solutions if they weren't previously talking about the consequences. And it showed that many users thought this would be useful in multiple states. That is, as they continue to make progress in research, they would want to re-enter into ImpactBot with a new impact statement and see how they can revise their research patterns. Moving forward then, I can show a quick demo in which, to start, this impact statement, you can see it loading through, doesn't actually include any negative impact use case or mitigation strategy. Therefore, they will get a 0% probability in both, and they're reprompted for the first one to consider what negative societal impacts their project may have. They're then given the room to edit it, at which point the user can go through and add changes that they want to address so that they better address a negative impact, and they analyze the impact statement. Now they've addressed a negative impact, but they still haven't added any edits for a mitigation strategy. ImpactBot makes this clear. So they're given the opportunity to once again rewrite it, at which point they'll see that they've found a 100% probability of both correctly, and they're given the opportunity to think about a deeper question, for which the user starts to impact statement write more, just so that they can think about those deeper questions. However, in the future, we might move towards a more successful conversation agent, focusing on the idea of edible thoughts and maintaining context. How can we better accept feedback? A new process for revision takes a generative approach, which combines the classification decision with the QA justification by using GPT-3. However, GPT-3 has length limitations, so an effective prompt needed to be designed with only one example impact statement. So we should think about the negative use case, mitigating the negative use case, and the feedback all in one for some kind of structure. However, GPT-3 is susceptible to stochastic parroting. In this case, with our prompt, by having a non-descriptive answer, we ended up with the same non-descriptive answer being parroted and repeated for a new impact statement that prompts the user to came up with. So how can we address this? Instead of just having the example statement followed by a series of questions, we should specifically list the questions with some kind of labeled dependency and justifications for the answer. This is a form of chain of thought prompting, which in fact yields new answers. Here's the adapted prompt for the sample impact statement, followed by what the user-generated impact statement is, and what yet again being prompted with questions to answer, at which point GPT successfully answers with a system of what's applicable, what's not, and how the user can appropriately revise their impact statement. This is significantly more effective even in identifying when negative use cases and mitigation classification should be touched. In fact, 4% more accurate on use classification and 6% more accurate on mitigation classification. Thus, ultimately, we can look to a future where we talk about creating and revising impact statements. However, in this case, GPT is really rigid. It requires a series of questions and answers. We have to have some kind of set prompt and an ask. So it'll lack creativity in being able to come up with more nuanced impact statements. Plus, the user might want more feedback, for example, asking for help on what common negative impacts are on a project like mine if GPT was already given the project. This is where ChatGPT comes into play. ChatGPT is able to take into account specific amounts of information, and as you provide more context, it can provide revisions and systems. This is extremely valuable for researchers in the field. However, it might limit researchers actually thinking about the ethical implications, as ChatGPT can do the work for them. So this is one of our final takeaways, paired with the fact that impact statements should be revisited throughout research, and that users rely on justifications and therefore need more interactivity. However, ImpactBot is a great first step in allowing users to more ethically think about their research potential and what to do next. Thank you.